Hi, a viewer called Mark asked if I'd be to have a look at this Bresser brand weather station. And what Mark said was, instead of him having to change batteries once a year on it, he's having to change batteries every week in it now. So I'm not sure, it does have a solar panel, so I'm not sure whether there's something wrong with the solar panel or some kind of charging circuit possibly, or so I'm not too sure yet till we get it apart. He's included the display, and more importantly, he sent along some nice goodies as well for me to enjoy, so thank you very much again for that, Mark, that's much appreciated. Right, so let's plug the display in, and it looks like it's searching on channel number 1. Well, obviously it's not picking anything up, so I'll just move the display out of the way. Let's have a look at this. So we've got a battery compartment on the bottom. I'll just remove that first. There's just one screw holding it in. And we've got some Energizer batteries in there. I wonder if I can stand this up without breaking it. Right, let's grab the test meter. We'll just see if we have any voltage in these batteries. So I'll go across all 3 of them. And there's only 0.7 of a volt. And we should have at least 4 volts there, 4.5 I would think, if there's 3 1.5 cells. Right, so let's just pop these out. 0.9, 0.7, 0.8. So the question is, why are the batteries going flat? Now I have had a look at a Davis weather station before, which I had to rebuild and change a lot of sensors and things on. And the way that one worked is we had a solar panel, and it used to have a supercapacitor inside, and the batteries were only used as sort of like a last resort if the supercapacitor dropped below a certain voltage. So perhaps this has got something similar in. Let's see, I've never had one apart, so we shall find out. Right. So it looks like we have some Phillips head screws all the way around the outside. So let's remove those. I shall just grab a screwdriver. Right, let's see if it wants to come apart. Let's see if I get all the screws out of the way first. Well, it has came apart slightly. Oh, there we go. Tell you what I'm going to do. I'm just going to unplug this connector here. Put this just to one side slightly, and we'll see if I can see anything in this part first. So there's a number of wires that seem to go to this solar panel. And I guess that's the rain sensor. So I don't know why we've got so many wires there. Let's just zoom down, because I think it might have something written on those that might give a hint. Let's just zoom down a bit. So we've got ground, 4.5, 4.5 VA, 1.5, and ground. And the centre wire here hasn't got anything marked on it. Looks like we've got serial clock and data as well, I can see there. And SHT, I remember that was the temperature sensor or similar on the other weather station that I looked at. That was the type of sensor. But that one had a special protocol. It wasn't I2C. It was using a legacy type protocol, so this might be the updated sensor. Right, but I think where the problem is going to be in here maybe. Not sure how that bit comes off. I can't see any more screws on it. It makes basically these two plastic pegs. There's one here and one here. Let's just try a little bit of leverage. So we have some kind of little power supply in here by the look of things. And possibly a supercapacitor. So let's get this little board out. Let's grab a pair of tweezers to get that out. And I think the supercapacitor's kind of glued in. I'll just put that to one side a second. I'm just going to grab the test meter. And we'll just see if there's anything in this supercapacitor. 0.7. So this may work similar to the other weather station that I looked at, where the solar panel charges up the supercapacitor, and then if there's no sunlight, it then falls back as a sort of emergency power to keep it going on the batteries. So the main thing it should be running off is this supercapacitor here, which should be getting charged from the solar panel. So I wonder if this supercapacitor has failed, or if there's a problem with the solar panel, or a problem on the charging circuit. I don't know if we can see any voltages on this supercapacitor. Yes, 5.5 volts. So what I might do, so it's 5.5 volts at 2.5 farads. So what I might do is try charging that up with the bench power supply, and then we'll see if it holds a charge. Right, I'll just set the bench power supply up. Right, so positive side is this side here, and negative side is this side here. So I've got the power supply set to 5 volts at 200 milliamps, and the voltage is steadily rising there. And hopefully it doesn't go off with a bang or anything. Right, now let's charge up to 5 volts. However, it does seem to be rapidly dropping. So it could be that there's even a short further on this. In fact, this isn't even plugged into the rest of the boards, such as the CPU and everything, because that's on that bit over here. So there's either a fault on this board here, or this supercapacitor could be faulty. So we're down to 4.6 volts already. I wonder if I should get the thermal camera just to see if anything's getting warm on this board. Right, I'll just go grab the thermal camera. Right, back with the thermal camera. And it doesn't appear to be anything getting warm on the PCB. However, there's a little bit of heat in the supercapacitor, which I've just charged up. So I wonder if this is just a faulty supercapacitor. Let's try removing it from the circuit board. Now there is some conformal coating on this. Let's see if the voltage continues to drop. And it is very slightly. I wonder what resistance we've got across here. Could be something like a diode gone short perhaps. I don't know, we've got mega ohms that way. Let's just try the other way. And we've got k ohms that way. I think it's this capacitor. So I think what I'll do, I'm going to see if I can order one online, and then when it comes we'll try replacing it and we'll see if that cures the problem. Right, I've ordered a new capacitor. I just thought I'd have a look, see how the rest of it works, see if it was the same as the other weather station that I looked at. Now this is the wind direction, and it looks like that moves a magnet round here, just at the bottom, just down here there. And it appears we've got two Hall effect sensors, so that must be how it works out what position this weather vane is. And then we've got the anemometer, or whatever it's called here, I can never say that word correctly, which is probably working on a very similar principle. I guess there's a magnet in here that rotates. In fact, one of those Hall effect sensors might be for this, and the other one might be for the weather vane. Those go to the little board here. We've got these cables here that go across to this side, and that looks like some kind of light sensor there. So that must be to measure sunlight, or the brightness maybe of the sun. I'm not sure what processor this is using. Let's see if we can zoom down a little bit more maybe. I think you can quite see for the conformal coating. Looks like it's running at 8 megahertz. And we've got a real-time clock crystal here, by the look of things. It looks like some extra I/O pins here as well. And possibly some pins for programming. Or it could be those there, or those might be jumpers actually, for different modes. Which is interesting. Looks like there's a part there for some kind of weird sensor or something, I'm not sure what that is. That's for the reset button, which is kind of fallen off. It's just down here somewhere. There we go. So I'll just move this to one side. And when I was having a look at this supercapacitor, it actually looks like it's two capacitors with some wrap around it. So I don't know if it's worth disassembling this just to have a quick look. See if we can see why it's failed. So what if it's two wired in series? Let's just see if we can get this bit of tape off. And it does indeed look like two capacitors on a little PCB. You can just see one of the legs just through there. So it's actually two capacitors wired in series. So I wonder if the electrolytics just dried up in these or something. Just get me cutters, I'll just see if we can chomp the end off this. We'll just see if it's like a normal capacitor inside. And indeed it just looks like a normal capacitor inside. So one thing I've just noticed here is there is two solar panels. We've got one at the top here which says 7.5 volts. This top panel just here. And then we've got another panel underneath it. If you notice, this one's got gaps in between and the top one hasn't. And the bottom one looks like it says 2 volts. So there's a 2 volt solar panel which is on this white and blue wire. and a 7.5 volt one, which is on the black and red wire. So I wonder if we can test those to see if we're getting any voltage out of them. I don't know whether my LED light will work or not. And the conformal coatings are probably going to help. Oh, we're getting 5 volts out of that one. Let's just try the other one. And get the probes on. Because obviously we're not in direct sunlight here, I wouldn't expect it to be giving out the full voltage. So yeah, so I would say the solar panels are actually working. So it definitely does point towards that capacitor. Right, it's the following day and the new parts have arrived. I just ordered these off Amazon. I'm not sure how good they are, but they look very similar to the original supercapacitor. Now, I've already cut the leads on this one and I've charged it up with the bench power supply. I've charged it up to 5 volts and it did have a little bit internal resistance because it did start dropping. But it seems to have stabilised now. It seems to be holding around 4.6 volts. You can see that that's not dropping now, whereas the previous capacitor was dropping quite rapidly and this one isn't. I'm just going to tin the legs on it. Right, that's attached. Let's see. I'll just be using the overhead light because it's dark outside at the moment. Let's see if there's any voltage going in there. Yes, well, it is charging up. Excellent. So I think I might leave it out in the light for a while. We'll see what the voltage gets up to. I might put it in the sunlight in the morning and we'll see what it gets up to. So one of the other things that Mark asked me to have a look at was this external sensor. And what's supposed to happen with this is it wasn't connecting and the light's supposed to flash every so many seconds, you know, every minute or something. You get a brief flash just to see that it's working, but it's not doing that either. I've just put some new batteries in because the old batteries that were in it were flat. And we've got 2.9 volts there. But we're not getting any flash or anything on it. I've tried pressing the reset button as well. I've just got a little reset button down here. And that should tell it to wake up as well, but absolutely nothing. So let's see how this comes apart. It looks like it's joined together round about here, so let's see if I can find a spudging tool and see if we can get into it. Right, back with the spudging tool. Something's moving. I've got the bottom open a bit. It's mainly glued at the top. There we go. The blob chips. Well, that's not good. Right, so I've got a couple of blob chips in here. Well, I've got a few test points. Again, this is covered in conformal coating. That must be the sensor down the bottom here. And I can see serial clock and serial data there, so it might be to use the scope and see if we can see any signals or whatever. There's also a few 0 ohm resistors. I don't know if there's any voltage test points on here. What I might do is get this under the microscope, then I can get the meter in shot as well, and then we can test some voltages. I think I'll do that. Right, got the microscope set up. Let's just see Do we get voltage to the board? Yes, just the conformal coating there. Let's see if we can see any voltage test points anywhere. Now with this having blob chips on, I'm not too hopeful. That's the transmitter part. And I guess this part here is the actual brains of it. Let's just see if the LED is actually working. Yes, so the LED works. I've got some 0 ohm resistors there. Let's just see if those measure okay. I could check the power on this sensor here and see if there's any power to that. 1 volts. Yes, so we've got power going to the sensor. I just wonder if one of these blob chips has failed. I'm just wondering what this line is here, because it looks quite thick, so it could be a power line or something. Yeah, it is indeed a power line. So we've got 2.96 going to there. So I haven't got a good feeling about this one. I don't think we're going to be able to go anywhere with this one, unfortunately. I might hook the scope up and we'll just see if we'll get any signals on any of these pins round here. Because they're probably from the microcontroller. Yeah, they're from the microcontroller. And this is the radio IC. So we could see if the microcontroller is chucking out any signals or whatever. Well, I don't think it is. Right, I'll just hook the scope up, we'll just have a check of that. Right, got the oscilloscope set up. And I've just tacked a ground wire just onto here, just so I've got something to use for the oscilloscope. And I've noticed there's a 10 megahertz point here. So I'm just going to have a poke on that. And we don't seem to have any oscillation, we just seem to have just a line there. I've got some other signals here. Clock, let's see if we get anything on that. Nope. EN, I guess that's enable. Yeah. Well, that actually seems to be trying to do something there, I think. Yeah, I'd say that's actually doing something, that one. Let's try a serial clock, which is... Actually, I think I had something there as well. Let's just see if I can freeze frame that. Yeah, so it looks like we're getting serial clock there. Are we getting any serial data? So why aren't we getting anything on the 10 megahertz clock? Couldn't be the crystal, could it? I mean, it could be that the oscilloscope, the impedance of the probe stopping the crystal from working when we touch it. I don't seem to be getting anything on there. I wonder if it's worth pulling this board out then, and we'll try replacing that crystal. I can see if I'll find a, I'll see if I can find a 10 megahertz crystal on something. We'll just try replacing that just to rule it out. You never know, might be hope for this one yet. Right, I've removed the board from the 1000 and I've removed the 10 megahertz crystal. Now unfortunately I don't have another 10 megahertz crystal to replace it with. What I do have though is a 12 megahertz crystal. Now I know this won't work, but it won't work because the timing will be off for this radio transmitter or whatever it is. But what I just want to see is if we do get a waveform on the test pin with this crystal, because we're getting nothing with the other one. So let's just try it. I'm just going to poke it just in the holes there. I've got it hooked up to the bench power supply because I had to unsolder the battery terminals, or desolder them. So let's go onto this pin here, and I'm just going to switch it on. I've just seen a waveform there. Let's try switching it off and on again. Yeah, on the scope I've got a waveform there now. For a while anyway. So let's just try. I'll switch the power supply off again. Let's just try the original crystal in and see if we get the same. Right, well, it's in the right place. I'm just going to go on the same pad there and switch it on. And we've got nothing. Switch it off again. Switch it on. And we've got nothing. So I wonder if this 10 megahertz crystal is faulty. It certainly seems that way. So I'm going to see if I can find or order or something a 10 megahertz crystal, and then we'll come back once I've got one. Well, I had a bit rake around in my parts boxes and look what I found. I think I bought these, must have bought this ages ago for some PIC projects when I was working with PIC chips and that and stuff. So let's give this one a go and see if it does anything. So I'm just going to poke it in the holes again. I'm not going to solder it in yet. Let's just put it like that. Let's get the oscilloscope probe. I'll just go on to the 10 megahertz pin again. And we'll switch it on. Hey, look, we've got a waveform. Now it's just gone off again there. Oh, hold on. I think the LED just flashed. I'll just get the microscope out of the way. One moment, please. Right, let's go on that test pin again. Just here. And we'll switch it on. And you can see the waveform there on the scope. Now let's just watch this LED here. There, it just flickered. Let's try switching it off and back on again. If we just watch the LED here, it should flicker around about now. There we go. Excellent. So, faulty crystal. Now I don't know whether this crystal is actually going to fit the case or not. But what I might be able to do is bend the legs over and just put some double-sided tape or something on just to insulate it on the board here. So I'm going to see if I can sort that out, and then we'll come back to it once I've got it kind of back together. So I thought I'd take an x-ray of the board, and you can see the crystal on the other side of the board there. And this is one of the blob chips, and it's interesting how it hasn't actually got any pads around this side. It only seems to have pads mainly on two sides. A little few pads here and a little few pads there. And pretty much the same with this chip. You can see where the crystal goes to this pad here. That's the test pad I was probing on. And it just goes straight into the chip. There's no other components or anything there. This must be the RF output side of the chip round about here. And these are probably the control lines. Thought you might find that a little bit interesting. Right, I've got it back together in the case with the batteries in. And it looks like it's picked up the signal there. 21.6, 67% humidity. So it appears to be working. Excellent. Well, at least that's one little job done. Now I've just got to wait for the capacitors to charge on the other part of it. So I've put this all back together, just temporarily for now. I've screwed the circuit board back down. What I'm going to do, I'm just going to leave it on the windowsill here. It's not particularly sunny today, it's actually quite cloudy today. But hopefully it should still charge up. So I'm just going to leave it like that for a few hours, and then we'll measure what voltage we have in the capacitor. Right, so this is the following day now, because I left it on the windowsill overnight and had to go out and do something. So let's see what the voltage in this supercapacitor is now. And it's fully charged. Excellent. So I just thought I'd put it outside next to my Davis one, just to give it a test. As you can see, it's a little bit windy here at the moment. So I've got the console all set up on the window here. You can see the outside temperature and the inside temperature and the wind speed and direction. I've just got the little temperature sensor just on the windowsill here. And I've put the console just next to the window here because our walls are literally 2 foot thick. And if we just look over there, you can see the actual weather station next to the Davis weather station that I repaired in a previous video. So excellent, I think that's it all working now. So a nice little fix on that one. Right, I'll see you in the next one.